Good morning, Earth Science students. Once again, this is a video lecture. This is video lecture number 2. Remember, we're on chapter 15, dealing with the atmosphere. And yesterday, we concluded with talking about gases in the atmosphere, in particular, how the composition of the atmosphere is changing in small but important ways, and giving the example of car exhaust, which emits gases into the air, which, like I described, is that like grayish cloud that you see if you from the back of automobiles. Now, continuing on, we'll move to slide number 16 now. Now, these pollutants, referring to the exhaust, mix with the oxygen and other chemicals in the presence of sunlight and form what we call smog, which is a brown haze. Now, if you've ever gone to South Mountain and looked actually back towards the city of Phoenix, you can notice the smog and you can see the thick layer of it. Now, another thing to consider that interacts with the atmosphere as well is we as humans burn fuel for energy. As fuel is then burned, carbon dioxide is released as a byproduct, and that goes into the atmosphere, and once again we see a mixing. Now, moving into slide number 18, we move into a new heading, and that says the makeup of the atmosphere, solids and liquids in Earth's atmosphere. Now, in addition to gases, Earth's atmosphere contains small solid particles such as dust, salt, and pollen. All those terms you should be familiar with. You've seen dust, especially the dust storms we have here in Phoenix. Salt you're familiar with. And pollen, is, of course, at this time of year should be very common in our understanding. It's what comes from the plants, the trees, and the flowers. Now, dust particles get into the atmosphere when wind picks them off the ground and carries them, like I described as a dust storm. And also, if you look at slide 18, there's a picture to illustrate that concept for you. Now, let's talk a little bit about how the pollen and the salt gets there. Well, the salt is picked up from the ocean spray. If you've ever seen the ocean when the waves crash and there's that like kind of mist that comes up, that's when the salt from that ocean spray is then entering into the atmosphere via that way. And then plants, of course, give off pollen that becomes mixed through part of the atmosphere. All right. Now let's get a little bit more into this. So the atmosphere also contains small liquid droplets other than water droplets and clouds. The atmosphere constantly moves these liquids, droplets, and solids from one region to another, hence via the clouds and just via the atmosphere itself. Now, an example, just to continue to hopefully clarify things, is the atmosphere above you may contain liquid droplets and solids that came from an erupting volcano that was thousands of kilometers from your home, which is pretty interesting to think about and kind of shocking to think that stuff travels that far, but that's just one means of which it does. Now, let's ask this question quickly. And let you think about this for a moment. What would happen if you left a glass of chocolate milk on the kitchen counter for a while? And I'm not talking like for a couple hours, I'm talking some serious time. Just think about that for a moment. What would happen? Well, moving into slide 23, let's talk about what would and potentially happen. Eventually, you would see a lower layer with a more chocolate separating from upper layers with less chocolate. And now, like a glass of chocolate milk, Earth's atmosphere has layers. Now, if you look on slide 23, it mentions those layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere, just to mention those. And those are 5 layers of the atmosphere. Now, the lower layers include the troposphere and the stratosphere. So those are what's considered the lower layers of the atmosphere: the troposphere and the stratosphere. Now, the upper atmospheric layers are as follows: the mesosphere, the thermosphere, and the exosphere. The stratosphere and troposphere contain most of the air. Keep that in mind. So the 2 lower layers of the atmosphere are where most of the air is contained. Now, just some more context as well, just something more to think about that directly relates to you, is you study, eat, sleep, and play in the troposphere, which is the lowest of Earth's atmospheric layers. A majority of our life goes on there. That is the area we're most thankful for, because that layer provides us the ability to live and to do those activities. Now, within those lower layers, it also contains 99% of the water vapor and 75% of the atmospheric gases. Rain, snow, and clouds occur in the troposphere, which extends up to about 10 kilometers, just in case you were curious about that. Now, the stratosphere. So we're moving from the troposphere to the stratosphere. We're still in the lower layers of the atmosphere. The stratosphere, the layer directly above the troposphere, extends from the 10-kilometer mark above Earth's surface to about 50 kilometers. If you look at the image I've posted on slide 28, you can see this illustrated out. All right. Now, a portion of the stratosphere contains higher levels of a gas, and that gas is called ozone. And remember, we briefly talked about that. Represented on the periodic table is O3. Now let's cover the last little bit of the lower layers of the atmosphere and finish our lecture for today. Each molecule of ozone is made up of 3 oxygen atoms bonded together. Later in this section, we're going to learn how ozone protects Earth from the sun's harmful rays. It's like a shield, and you notice I included some different examples: Captain America's shield, Black Panther's shield, Link's shield from Zelda. All right. Well, have a nice day, students, and if you have any questions, you can leave them in the comments below. Send me an email. Thank you, and have a nice day.